Okay, I wanted to share the notebook from, I forgot when I was doing all this. We hadn't really looked at any raster files. And they're really important in climate science because if you want to look at land change, deforestation, things like that are impacted by climate, we really need to just have those tools in the palm of our hands. And this is the last set of skills we're going to learn in this little bucket. So you're going to open up your Jupyter notebook. We've done this, and you're going to pip install this. We're going to be using the scikit for our cluster analysis, our k-means. So we just load all of this up. And I found a satellite image that I wanted to work with. I found an area of Brazil. I found Sentinel data. I used the true color. I downloaded it, and then I uploaded it to Colab. And this way, it's so simple because then I can just take the link and put it into the code here. And we're going to be reading the images, right? We have to read them because these pixels are all going to fit inside clusters based on their width, height, and we'll be able to see the cluster of the bands. So here we have everything, the code's written. And I believe I pulled this off of GitHub for working with deforestation data. So you kind of have to know how to rework the code a little bit, but there's no reason to have to do the universe if it's already done. So the k-means clustering, and I picked the metro. And so you can kind of see the area that I was looking at in Brazil, and we can look at the output of the data. We see a lot within the, say, high twos, high to low twos area in those clusters. So we want to go look at that cluster. And you see that here. What this is telling us is that we have this many pixels and this many bands. And that's important to know because you have to know how many bands you have so that you can get a proper output. And the pixel value has to come first. If for some reason it's switched, you're going to have to switch it back so that you can run your code. But if you get good quality Sentinel image, you shouldn't have a problem. And this I guess I ran it a few times just to try to clean it up, making some changes to the code. I want to make sure that my number values, I want to make there's 0 here. Not always 0, but if you pick a really dense area, I was originally looking at a really obscure area, and that because I was doing a project in that area, and then I just decided Brazil has so much good satellite data. And so if you had zeros, you could reshape the data and decide, how do you want to shape that? Replace it with zeros, just use the mean of the surrounding area. You have options. So now you have your data ready to go. I just picked 5 clusters. Usually you can play around with the clusters and see how your data looks, whether you need more or you have too many. 5 is a good place to start. And it's showing me the cluster distribution right in here. So that's good that they're not empty. Sometimes you get an empty one. So you can calculate the means. So we have 5 clusters. Remember, the index starts at 0. So 0, 1, 2, 3, 4. Here are the values that you could see here. And you can create masks for these layers. You can look at them. So that was 0. Mask for cluster 1. Cluster 1 wasn't showing up right. I don't know why. Here's cluster 2. 3 and 4 of the same area. So you can just get an idea of what these look like. I like this. You can do the original bands. You can code them here and just see the different densities. And then you can do an overlay of those clusters on the actual image that you generated. So now on top of the image, we now can look at the pixels and the bands and how they're displayed and say something about the deforestation, the amount of agriculture in the area, just by looking at the characteristics of our bands. And I suggest you do this maybe with some data that you're interested in, an area that you're interested in, and you can just plop it into the code that I've already generated here and do some land analysis.